Well, welcome again. I am Leslie Burkus. I'm the Executive Director of the Urban and Community Forestry Society. We are so happy to have you here today. And we're extra excited because this series overall is sponsored by Bartlett Tree Experts, and we are hearing from Bartlett Tree Experts. Together with Bartlett, we share the goal of raising the bar of urban forestry and research and making sure that you feel you're most confident in the decisions you make, because we rely on you to grow the trees in our communities. So, fortunately, we have Nick Martin with us today. Nick, I'd love to have you share a little bit about Bartlett and your goals for urban foresters across the country.
Yeah, thanks, Leslie. Appreciate the opportunity to be here and really happy to have this new partnership moving along. So, Bartlett Tree Experts was founded by F.A. Bartlett in 1907 when he essentially decided that America's trees needed saving. So, that's really what got us started. And we are currently managed by Robert Bartlett Jr. So, it's the fourth generation family ownership and management. So, as the company, we are still family owned, which is awesome. But our overall mission, we're committed to providing scientifically based landscape management recommendations, delivering quality service safely and at a level that meets or exceeds industry standards. So that's what we kind of hold ourselves up to. As a company, we have over 3,000 skilled arborists in over 154 offices, and that's 38 states, Canada, the United Kingdom, and Ireland. Uh, so we specialize in tree preservation. So through tree pruning, shrub pruning, plant health care, soil care, structural support, lightning protection, anything we can do to help preserve trees. That's what we specialize in. Now we obviously remove trees as well. Those instances come up, but we always much prefer to try to preserve our trees for the long term. We also have an amazing team of consulting arborists throughout the company footprint. Our Hort Science Bartlett Consulting Office in the Bay Area, Urban Forestry Services, Bartlett Consulting in Seattle, and we also have a great team in the UK as well. And we have a group of consulting advisors and arborists throughout the entire company footprint also. So we handle all kinds of consulting projects, inventories, management plans, tree risk assessments, urban forest master plans. So we try to specialize in everything that we can. But today, we're very, very lucky to also have Bartlett Tree Research Laboratories on our team. So F.A. Bartlett established the research laboratories in 1926 on the experimental grounds outside Stamford, Connecticut, which is still named the Bartlett Arboretum, although it's no longer part of the company. But today, our main research and experimental grounds, where Matt works out of, is located just outside Charlotte, North Carolina, and also has about a 350-acre arboretum as well, where we do a lot of experiments throughout the grounds. So we have about 14 PhDs on our team now, again, throughout the company footprint, and we're also currently working on new research in arboretum grounds in the Reading, UK area, and also in Oregon. So luckily, you get to hear from Dr. Borden today on Beech Leaf Disease, which is amazing. I've been able to work with him on a few of these, and it does. He's really good and presents it in a great way. But I think overall, picking up where Leslie was talking about kind of our goals, this really got started with Rob Allen, Leslie, and I wanted to see how Bartlett could get more involved with urban forestry. And beech leaf disease was a great way to start, right? That was something that came up quickly, could have some devastating impacts. And so we wanted to get ahead of that. And I think through our partnership, and we can help all of our urban foresters stay up to date with some of these crucial items that come up and just be able to provide the education that we can. So really looking forward to the opportunity, Leslie.
Yeah, thanks, Nick. Appreciate that. And again, very much thank you for your support of this and all of our learning series. And overall, we thank our other sponsors, Planet Geo and Eocene, and you as members. If you are a member of the society, we really appreciate your support. It's your membership dues, your support that helps make this and other programming possible. And really, our goal is to help bring you together. If you're not a member, we really hope that you'll join when the time is right. So again, just a few more housekeeping things here, a little bit more intro, and then I'll be turning over to Dr. Matthew Borden, where he'll explain the causes and impacts of beech leaf disease. I'm here in the Midwest, not as many beech trees here, but I'm really eager to hear more about it since so many of our members are dealing with this. treatment programs that are being developed and researched, and then stressors and environmental factors for more holistic tree health. So we'll hear from Dr. Borden on that. We'll have time for Q&A. And then at the end, we will drop the CEU credential form so that you can submit your ISA information, and we'll submit your CEUs on your behalf. So as we get started here, we'd really love if you drop your name and where you're from in the chat. It's great to see where folks are coming in from and joining us from across the country and globe. So please put that in the chat. This webinar is being recorded and we will post it later onto YouTube. I just covered CEUs. We will submit those on your behalf. And at the end, we'll have you put questions in the chat. You can use the Q&A little question button that's at the top, or we can bring you off mute at the end as well. Just a little bit more about the Urban and Community Forestry Society. If you're not familiar with us, our mission is to build the confidence, competence, and camaraderie of all professionals who manage trees and forests to create and sustain more livable communities. And really, just to break that down even more succinctly, we want to be the membership home for the professionals who make and support daily tree planting and care decisions. If you decide who, what, where, when, or how a tree is being cared for, coming down, going in, however a tree is being managed in your urban community, we want you to be here because we have more power together. We have more knowledge that we can share with one another. And just like doctors, lawyers, nurses have a professional society, you as an urban forester have one as well. And UCFS is that for you. So we really welcome you here. Our job is to help, again, make you feel you're most confident in your decisions you're making. We do that through a variety of things like this learning series, our City Trees publication, which you see a picture of here. Hopefully you are receiving that. It's a great publication, free digitally, that you can share with your boss, maybe the public works director, so they understand the work you're doing a little bit more. Maybe you share it with your friends or family who have no idea what you're doing as an urban forester. Just a way to help share the information and also make sure that you have special interest stories, technical know-how, all within City Trees. Some of our membership benefits are our mentorship program, discounts at our annual conference, and being able to attend our Municipal Forestry Institute, which is open to all, but definitely discount if you are a member. And we'll be opening up that in August for registration or application. And MFI will be held at the end of the last week of February every year. So if you need to start budgeting for that or plan for it, we really hope to see you at the Municipal Forestry Institute in 2026. A couple other things that are coming up for the rest of the year. Our learning series in April will be Urban Foresters as Change Makers. How do you really take ownership of your role to move urban forestry programming within your community? Our May learning series is the future of inventories, especially focused on smart tree inventory. And then Bartlett learning series will be back with us, or Bartlett will be back with us in June for another learning series. And then we'll also have a career compass one for young and emerging professionals focused on resume building, getting an interview. How do you conduct yourself, especially in those really formal government interviews? We'll be posting that very soon. And with that, thank you again to our members. If you're not a member, hope that you'll join when the time is right. And I'm going to stop sharing here and turn it over to you, Matthew.
That's a great intro. Thank you, Leslie.
Yeah.
All right. How's the screen look?
Looks like it's coming up here. I can see it.
Super. Well, good afternoon, everyone. Thank you for joining today. I hope this will be informative. Since you all are primarily urban forestry professionals, I'm going to try to spend as little time as possible on the more true forestry side of this problem. And while that's very interesting, we are going to try to stay focused on more the urban beech and situations that you all probably deal with on a regular basis. Also great to see a couple of names that I recognize in the attendees. Grant, good to see you on here. One of my former bosses. So, well, let's get started. This presentation is going to cover a lot of research from our whole BLD team. That's led by Dr. Andrew Lloyd. I work closely with him on these projects, and we have a fantastic team of technicians and extension technical staff as well that have been a huge help here. So my goals for today are to help you all understand the available BLD treatment programs that we've developed and where they may be appropriate. They are both very effective where they are appropriate. So understanding that is, of course, key. And then we're going to try to open the discussion of an IPM approach to BLD and what that means for you all as tree professionals, because there will be a lot of decision making involved. And we are just starting to get into the world of decision making now that we have management strategies. So it's a very new thing. And then if we have time, we'll discuss next steps as we look to the future of beech. And if there is time, I'd be happy to chat a little bit more about what we're doing on the more forestry perspective as well. So we'll see what we can get to today, and happy to take any questions at the end. So please save them, and let's get into it. Our host of concern, of course, from an ecological forestry perspective, is the American beech. From an ornamental perspective, we are also very concerned about European beech, Vega sylvatica. These trees are very high value, important trees in the landscape and nursery trades all over the northeastern United States in particular. So it depends which industry you're coming from. If you're ornamental landscape, Vega sylvatica is a big deal. If you are really just concerned about native forests, then the focus is primarily American beech, but BLD affects both. So concern over BLD is far-reaching. Often, especially us as scientists, tend to get a little bit siloed in the specific part of the sciences where we work, but this is a disease that does impact a lot of stakeholder groups. Of course, there is the forestry folks doing invasive species management and all that. But then, of course, beech are in many, many residential and commercial landscapes as well, so the urban environment. Nursery industry has already been quite affected by this, as they've taken on often self-regulated quarantines to stop selling beech, or locally induced quarantines. Arboreta and the plant conservation community is concerned. And then, of course, BLD is affecting us here in North America, but what we learn and what we have observed is going to be quite useful to folks outside of the US as well, who are concerned about the forest health of the native range of Vega sylvatica as well. So many stakeholders, and it's been a really neat process to learn about this new problem. So we're entering the, 13th-ish year of BLD in the United States. Started around 2012 here in the general Cleveland area of Ohio, and since then has spread quite astoundingly rapidly to much of the northeastern United States. It's been really bad in Maine this past year, and we found some pockets of it in Northern Virginia. It's gotten as far south as about Richmond. So this is the primary range of American beech density. There are American beech a little bit further west and further south that is shown on here, but it does start to get less dense the further south you go, even though the range stretches all the way to Florida and much farther west, of course. But we're not really sure how quickly it will move in those directions, given the spatial distribution of beech. So the way we've talked about BLD has shifted over the past few years. We've really started to describe this as a progressive disease. And by that, I mean it is a gradual, a little bit more chronic rather than acute affliction for these trees. And that doesn't necessarily mean it's always slow, but for example, in Ohio and Ontario and some parts of the country, the best estimates were that maybe it could kill the tree in 7 to 10 years. But then as it moved further east into the Northeast, especially coastal communities in New England and Long Island, it became obvious that that was not necessarily the case for all sections of American beech being affected. Some of these coastal regions were seeing really severe disease just within a season or two, starting to kill trees. So there are differences based on where the disease is, but in general, we see this progression of leaf banding as sort of the early stage symptoms. And then after a season or two, as the nematode populations ramp up, you see worse symptoms such as severe crinkling, smaller leaves, dwarfed leaves. They're very corrugated, almost kind of like cardboard in some cases. And then once you get these high numbers, you start to see dieback and bud abortion. And that can quickly cause canopy loss and defoliation. But as with defoliating insects and such, how well the tree responds to that and tolerates that often depends on the pre-existing health of the tree. So it is different in different areas again. Here's our causal agent. I think it's very well recognized by now that this nematode is certainly appearing to be and acting like an invasive species. We're pretty confident that it came from Japan originally, where it affects Fagus crenata, Japanese beech, but it does not cause severe symptoms in Japanese beech. And the reason I highlighted the subspecies there, McCannii, is that this is how we currently describe this organism, Lidolenchus crenati McCannii. But there has been a fantastic expedition led by Dr. Bob Mara and Paulo Vieira from USDA ARS and Danny Martin from Forest Service and others who have gone over to Japan to learn more about this organism. And it's fairly likely in the near future that maybe we will start to just refer to this as Lidolenchus crenati. But we, the scientific community, are waiting anxiously for Bob Mara and his team to publish what they have found from their expedition. So we look forward to that. Very exciting. If you want to really get into the weeds about BLD and how it is actually affecting the trees, this is my recommended reading list. So top left, that's the paper from Paulo and his collaborators that really delved into the cellular changes, what is happening in the beech leaves as a result of the nematode's presence. And then the other papers are looking at the physiological impacts of the disease on the trees. And together, we've gotten a much better idea now of this, again, what I described as a more progressive problem. So if you're trying to explain beech leaf disease to the layperson or your constituents in your towns, this is how I typically try to explain it. So in a normal situation, right, a normal healthy beech tree, the tree is investing resources into its leaves, the little solar panels of the tree, you might say. The leaves are photosynthesizing. They're producing the energy, the food for the tree, the photosynthetic products. And the tree uses those for growth, for defense, for all the things a tree needs to have energy to function. That's the normal process. When a beech tree has beech leaf disease and high populations of these nematodes causing cellular changes in the leaves, those diseased leaves are requiring more of a resource investment, not less. So those dark green bands, those thick tissues, those corrugated leaves, that's still a lot of resource investment, but it's like putting out a field of solar panels that don't work, right? It's a big resource investment that's not giving back to the grid, if you want an analogy. So the photosynthetic rate is reduced. The leaves are not functioning as they should be. And so as a result of BLD, you see this gradual depletion of carbon and energy stores that can result in slower growth, poor defense, and eventually bud loss, bud abortion, and dieback as the tree gets weaker. So eventually these beech trees, depending on how quickly they're affected, will probably start to enter the tree decline spiral. So where are we in the state of BLD management? So for beech-dominated forests, there are very few management options yet to be proposed, and to be quite honest, the ecological impact of beech leaf disease will probably be quite devastating in much of the beech forest in North America. But we are at the point, thankfully, for specimen beech preservation, we have developed highly effective new tools, which introduces the possibility of IPM programs for beech leaf disease. It's not necessarily a cure-all for every tree, but where appropriate, our programs can be very, very effective. What has really been interesting to me is that once you introduce a management program, suddenly it opens up all of these new discussions of what is the threshold? What does a successful treatment look like? Or what does a failure look like? And honestly, it didn't really occur to me until we started seeing control that we need to address all of these other threshold and situational needs as well to provide a proper recommendation. So it's been fascinating to see this IPM program develop. This is just a visual representation of our search for management tools that we've been conducting over the past 4 years or so. These are all products that we put on a short list of things to try for a wide variety of reasons. Some had nematocidal properties, but were not labeled for trees. Others were labeled for trees, but might have nematocidal properties, etc. I'm not going to talk about all of the things that did not work because we simply don't have time for that today. But at this point, we have tested, I think, everything on this list, either us or collaborators, and much of it is published. I'm just going to focus on the programs that have seen the best success. And those are programs revolving around the active ingredients, fluopyram and thiabendazole. So when we are setting up these management trials, I want to describe the goal. What exactly are we targeting here? So in a normal BLD disease cycle situation, you will see the damage occur when those leaves expand in the late spring and early summer. In the midsummer and fall, the nematodes are active in those leaves and moving into the developing buds. And then once they're in the buds, they are causing the damage that you see the next spring. So it's sort of a delayed effect from when you see the damage from when it occurred. So the goal for our management programs here is to target Lidolencas, the nematodes, as early as possible prior to their summer population expansion and migration into the buds. And if we can do that and protect those next season developing buds, then we would expect to see a healthy flush of leaves the next season. So again, there's a delayed effect because of the normal life cycle of this nematode. But that is our goal, to knock out the nematode population before they have an opportunity to make it into the buds that provide the next season's growth. You cannot reverse the banding symptoms and the damage that has already occurred. So here's a map of at this point, I've lost count, the number of field sites that we have set up and have contributed to our current recommendations. The different colors and icons and whatnot are different trials looking at different things. But this gives you an idea of where we conduct these trials. Obviously, I'm in Charlotte, North Carolina. We don't have BLD here, thankfully. So we travel up to where BLD is in different kinds of environments, some urban landscapes, some forestry sites, different densities of beech forested sites to study this problem where it occurs. And when we do that, when we do these trials, we are looking at the visual canopy ratings, so things like defoliation or thinning and the amount of canopy with banding. But then we're also taking samples from these trees. We're looking at the populations of nematodes in the leaves late in the summer, looking at populations in the developing buds, either sampling in the fall or late winter, to get snapshot pictures of what's happening in these populations before and after treatment, and then relate that back to the visual symptoms that we see. This is a video I took from the margin of BLD in southern Pennsylvania. This particular site has only had BLD for a season, and already there are just shockingly high numbers of Lidolencas nematodes in some of the leaf samples that we pulled. So that site's going to look pretty rough next spring. And we will be there next spring to confirm that, because this is one of our new study sites. Very exciting. But when you see these kinds of numbers of microscopic parasitic worms coming out of a tiny piece of a beech leaf or a beech bud, it really drives home the point that this is a devastating parasite. You can find 10,000 nematodes and up per gram of bud tissue. I mean, it's a lot of microscopic worms in these tissues. It's not like an earthworm where you take a scoop of dirt and there's one or two. We're talking probably billions, if not more, nematodes per affected beech tree. So very high population growth potential. This is the first success that we had in the field trial, and this is published if you want to read that. It was our paper that came out in 2023, I believe. This was our first field trial using fluopyram alone, where we saw a reduction in beech leaf disease symptoms, and this kickstarted a whole series of additional fluopyram field-based field studies. I don't have time to go into all of them, of course, but I do want to mention that fluopyram is what is considered a next generation nematicide. It was one of several nematicides that have been developed in recent history to replace some of the older generation, far more toxic nematicides, things like oxymel, methyl bromide, fumigants like that sterilize the soil to kill nematodes. So it is a powerful nematicide, but it's also a pretty good SDHI fungicide. So there has been a lot of confusion there in using fluopyram because the particular product we use, Broadform, is a fungicide. However, we are exploiting the distinctly nematicidal properties of that active ingredient for this disease. So I don't want there to be confusion there. And there are other fluopyram-based products on the market, but for a number of reasons, we have to use Broadform currently. That's the only option available and labeled for BLD. So this is what a lot of our field sites look like, and this would be a successful site where we put out this treatment. We applied a program of fluopyram applications in mid to late summer in a series about 3 weeks apart, continuing through the early fall. And in the non-treated trees, as this progressive BLD progresses, those trees got worse, more canopy with BLD. In our treated trees, we saw a large reduction in the amount of canopy with BLD symptoms. So successful treatment. And then this is looking at canopy density. So inverse of dieback, where the non-treated trees, the canopies were less dense or more thin with more dieback, and our treated trees showed some recovery in canopy density. So this is a very good site. This will be published in an upcoming manuscript if you want to see all of those details. I'm working on that manuscript now. This, however, was the exact same treatment program and absolutely no differences between treated groups and untreated groups. Almost exactly the same. So what was the difference? Well, in this particular site, we were rating fairly young beech in a forested site, a pretty dense forest. And it turned out that during the course of the study, the overhead beech, the tall beech canopy, became severely affected by BLD as well. And this has started to teach us where fluopyram-based applications may be appropriate or not. So in this case, we were offering some protection to the understory beech, but those treatments were just completely swamped out by what we're pretty confident was the millions of nematodes quite literally raining down from that overstory of severely affected beech. It wasn't severely affected when we started the study, but over the course of the study it was. So site differences are important. Here's another very successful study that we got all excited about last season. As we've learned more about fluopyram, we started to tweak, the timing of application, the number of applications, and especially the dose. What is the optimal dose? We want to put out enough product for the treatment to be successful, but not more product than is necessary, right? That's a good IPM principle to go by. So in this field study, we had 50 beech in a nursery on Long Island, and we knew from lab bioassays that these Lidolenchus nematodes were extremely sensitive to fluopyrams, quite selective for them. And sure enough, when we tested this in the field, rates as low as 1 fluid ounce compared with the labeled rate at the time of 8 fluid ounces per 100 gallons were statistically equally as effective. Pretty remarkable results. We looked at the buds as well, and it was exactly the same as this, just incredible 98 to 99% reduction in those populations in all of the treatments. And here's what that field site looked like on the ground. There are 4 of our treatments in this section of the block. They happen to be lined up. And these are actually buffer trees, but you can see those untreated trees there, much, much thinner. They were already putting on a second flush of growth as a response to poor initial flush of growth. And there's one of our true controls at the end. So again, this will be published quite soon in an upcoming manuscript. As a result of our initial fluopyram trial and then now these subsequent trials, we got a 2EE recommendation for Broadform for control of BLD. This is the original, and it had 8 fluid ounces per 100 gallons. Thanks to that dosage study, We were able to get that dropped to 4 to 8 fluid ounces so that you are now legally able to put out half as much material as before. Optimally, we wanted that to be even lower, maybe 2 fluid ounces per 100 gallons, but that didn't quite work out. But we did get some improvements on this label. We also expanded the application interval to up to 21 days. So that label is for pretty much all states, just not Long Island. If you happen to be on Long Island, there's a 24C for Long Island as well. Here's a nice example. This is Old Westbury Garden on Long Island. Mr. Bartlett was kind enough to donate a large fluopyrim-based BLD program. So summer, these trees look fantastic. These were affected by BLD. They were put on a foliar program. Despite being pretty large trees, they did a good job of getting decent coverage on these trees. Trees look much, much better. If you turn around from where I took this picture and look at the other side of the beech alley that was not treated, all the way down this alley, these beech are quite still severely affected by BLD. So single season program, stark differences. So for this program with fluopyrim-based products, what is the good and bad candidates? We would say that good candidates are smaller beech where you can get good full coverage from a foliar application, like beech hedges, beech in nurseries. Broad form is labeled for nursery use. So small to medium-sized trees where full coverage is possible, trees that were previously pretty healthy, no other major issues. We don't want to treat trees that are dying of other things, right? Poor candidates for BLD treatments using fluopyrim would it be small beech in a dense forest with an overstory of infested beech, or very large beech where you can only get coverage on the lower third of the canopy. That would not be wise. Beech adjacent to bodies of water, because the broad form label stipulates don't spray where there's risk of drift into water. And again, beech with a significant dieback already. So this program can be very effective. Our next step is really to keep whittling it down. So our initial program was very comprehensive, 3 applications of broad form. We believe that once we get the timing right, we can probably get that down to 2 applications or even 1. And there is already some building evidence that we can get good results with a single well-timed application. So we're continuing to study this in detail and make recommendations, but it's so far so good. I'm going to roll right into this next program so I don't run out of time here. Okay, so small trees, good coverage, we're done. What about large trees? So we've now developed a root flare injection program, which a lot of you will be very familiar with. This is using Arbitect 20S. Arbitect is the same fungicide that our industry has used for Dutch elm disease treatments for a long time. Developed back in the 70s and 80s by one of my mentors, Dr. Jay Stipes, and he and his colleagues really pioneered the use of these tree injection benzimidazoles for Beech Leaf Disease, for Dutch elm disease management. We went back and used a lot of that original science and logic and tested it against BLD, because thiabendazole, the AI, is not just a good fungicide against Dutch elm disease and sycamore anthracnose, it's a very potent nematicide as well. And in fact, it was used as a nematicide long before we started using it for Dutch elm disease. So this is published and the paper came out in February. You're welcome to delve into this in more detail if you'd like. This is generally what it looks like. This is a macro injection system. So using either one of these systems with a larger tank or trash can in some cases, or a 3-gallon pump tank like this. Those can both be used for this treatment. This requires a lot of technical skill. It's not as simple as putting some product in a backpack. And even that has variables, nozzles, droplet size, spreader stickers. Even more so with tree injection. This does require additional training. We do a lot of that, but of course the manufacturer, Rainbow Ecoscience, which is also the distributor of thiabendazole as Arbitect, they have really good educational resources as well. They do trainings, they do webinars on tree injections, so feel free to reach out to them if you need support with understanding how to do these properly. Again, this is published, so you're welcome to delve into it in more detail. But I wanted to highlight a couple of things. In our thiabendazole studies to date, we published data from 3 sites, 2 in Ohio, 1 in New Jersey, at different application timings. So in this treatment, early August, we saw non-treated 3,000 nematodes per gram. I believe that was leaf tissue, down to 900. So significant reduction, but 900 is still a high number. We need to get lower than that. An early August timed application, and notice the rates. This was a much lower rate, by the way. We saw a reduction down to 179, so better. In our mid-July application, which occurred before the nematodes were able to start migrating into buds effectively, we saw over 99% reduction and just an average of 9 nematodes per gram of tissue. So that is a significant reduction where we would not expect to see many symptoms if we reduce the population that much. We've also got good data now from one of our sites that we put out in August of 2022, showing that we could get 2 seasons of good reduction in BLD as a result of a single application. So much like Dutch elm disease, where it's a once every 3rd year treatment interval or so based on need, we're pretty confident that not only is this not an annual injection treatment, but we probably won't even need it to be a once every other year. We'll probably be able to get 2 seasons of good suppression of the disease out of a single application. So it might be once every 3rd year. But again, we're still learning about this as well. We're also still playing with the dose. In this particular study, getting 2 seasons of pretty good reduction, that was a low dose of the product. On the label, we use 4 times this amount. So here's one of our other sites in that trial. This is untreated controls, roughly the same year-over-year change in canopy with BLD. We saw a really good reduction in the vast majority of the treated trees. What's really cool is we counted the nematodes on that site as well. Same information I showed before. Excellent reduction in the nematodes. So this product is able to quite successfully directly kill these nematodes in the leaf tissue. Very good news. The site where we applied it too late in early August, here's what it looked like. Really, really interesting. So the trees that we had treated too late had a reduction in nematodes, but not quite enough. So we still saw a lot of banding in those leaves. But the untreated controls on that site were ubiquitously much worse off with already pretty severe defoliation and canopy thinning. So, and here's what that looked like from the ground. I think same trees. So untreated tree, treated. We had a reduction in nematodes, not enough, but it was enough of a reduction that at least we didn't get severe dieback. So again, this was the worst site of the lot, and we learned a lot based on this timing that we can do much better than even this. So we put a lot of work into getting Arbitect registered in most of the range of BLD at this point. So if you are going to do these applications, you must have the 24C special local needs label on hand for your state, of course. So we've gotten Arbitect 24Cs for control of, or for management of beech leaf disease, registered now in all of these dark green states. And Delaware is pending. I expect that will be registered within the next couple of months. Maryland was just registered a couple of weeks ago. That finally came through. But in all of these states now, you can legally use Arbitect 20S for BLD management. So that's very good. So in summary, thiabendazole treatments can provide significant therapy to affected beech trees by reducing the nematode inoculum, we call it inoculum, much like fungal diseases, and disease severity. This is the preferred treatment for large beech 8 to 10 inches diameter and up. Beech near water, because there's no risk of drift from the foliar application. Woodlots, or where longer retreatment interval is preferred. So again, we're always setting up new sites to fine tune these details, but our next set of trials will optimize that timing even further, look at June applications compared with July applications. And then we're also still exploring the rates as well to see how long the different rates will last. So you have these treatment options. Are these for every tree? No, and I really want to hammer this home. We want to be careful that we are still evaluating our beech trees from a more holistic perspective. So BLD is by no means the only problem we have with beech, right? We have Phytophthora bleeding canker. We have Kretschmeri as a major problem in mature urban beech. This is spider mites, probably not something we would normally treat for, but nevertheless, I threw it on there. Beech bark disease, major issue, of course. Beech bark scale, various urban problems, bad pruning, thinning canopy, severe compaction. The last couple of seasons, I've had a lot of complaints about the European beech, woolly beech leaf aphids on European beech. Buried root flares, improper cultural practices, beech anthracnose, and other issues as well. So this becomes a question of knowing how to evaluate the beech, figure out which ones you want to preserve and are worth this investment, or which are maybe best not treated and replaced with something else eventually. So I'm not recommending go out and treat every single beech by any means. Here's a beech in Newport, season by season change before and after our fluopyram program. Canopy looks great. Honestly, I could not find a single leaf with BLD banding when I went back to inspect this tree. But this begs the question, what is the acceptable threshold here? And who decides? If I had found 10 leaves with banding on this tree, is that still a successful treatment? Well, I would argue yes, because the vast majority of the canopy is now back in a good functional state. But this is a big topic of debate. I've had some extension personnel say that, 90% control is not enough. Well, not enough for what? What is the situation? 90% control is not enough if your goal is 100% eradication, but 90% control might be enough if your goal is to get that canopy back into functional, longer-term sustenance. So these are questions that we as tree professionals need to be aware of and need to start producing guidelines for. And that's what I intend to try to work on this year, and often relying on folks like you to give feedback. These are different situations. So beech hedges in Ohio, really nice Vega sylvatica hedges. What's the threshold here? We got these down to almost no symptoms at all. Is that successful? I'd argue yes. This is an injection that we're doing on large beech, but we're trying this on forested beech as well. So yeah. At what point will the tree be able to thrive despite local ongoing BLD pressure? That is to be determined. But we need to see what becomes of this long term for sure. I'm about out of time, so I'm going to roll through this really quick. If you manage forests, this is going to be a problem. We were already in a state of very poor native tree regeneration in many of our eastern forests. With beech leaf disease opening up that canopy that provided a lot of shade, we're going to see invasive species encroachment almost undoubtedly. One of our sites is full of multiflora rose and barberry, and it's not going to be fun to see those grow on that site as the canopy thins, but we will measure it and learn something. So consider this. Shout out to Jean Epfin at Rutgers. If you want to learn more about beech ecology as it relates to local fauna, she has a nice seminar on YouTube where she loves to talk about the ecology of American beech. And then lastly, we are moving swiftly into a much longer term project looking at silvicultural practices for American beech. So we are thinking about this for sure, thinking about people with forest sections, thinking about how we might be able to use silvicultural practices like thinning or selective treatments of certain healthy mature beech to preserve patches of beech-dominated forests. So this work, we've already got it underway at a couple of partners, really good land trust sites that we look forward to working with for the next 5 years. But this will be a neat project to see if we can actually manage BLD at a forest stand level. Won't mean complete eradication because this disease is not going anywhere, but we want to know if we can manage it and preserve some of that future reproduction potential. So with that, another shout out to our leadership. We couldn't do this without the enormous support of Mr. Bartlett. It's really, really nice as a young scientist to see private industry putting so much of their hard-earned resources into the sciences and into very practical information that we can develop and then share with the greater community. So big thanks to them and our other collaborators as well, and co-authors on our papers. That's it from me. I think we have a few minutes for questions, and again, I'm happy to stick around as long as possible. Thanks, Leslie.
Yeah, thank you, Matthew. Well, as we get started with Q&A, please feel free to drop your questions in the chat. You can raise your hand. We can bring you off mute. And then again, we will drop the CEU link at the very end of this webinar. Matthew, there was one question as you were sharing the first treatment option that was a canopy spray, and you addressed it the next one with the next treatment option, but I didn't know if you had any more to say about the systemic treatment option versus the canopy sprays. And that might be too broad of a question, but one person had asked about the systemic options versus the canopy spray.
Let me try to find that exact language if I can.
Any systemic materials available to avoid canopy sprays?
Yes, that would be the thiabendazole-based treatment. Thiabendazole is fully systemic, moves up the canopy from where we inject it and the root flare. Yes, we're also looking at possible soil drench treatments, but so far we have not found any that are effective.
Thanks. The next is more of a statement. You should take into account the threshold as a nematode disease, which often does not take into account 100% mortality of the nematode.
Absolutely. Oh, that's from Paulo Vieira. So Paulo is literally the expert on how these nematodes are interacting with the beech leaf cells. Yes, absolutely. This is going to have to be treated and considered differently than a lot of the other diseases we're familiar with. And 100% eradication or mortality is not the standard for how we treat nematodes that are plant parasitic nematodes. We manage them often quite successfully, but having a zero number, especially when you're trying to handle quarantines and such, is not really the right way to approach this problem.
Thanks. Another question, when should you use the foliar application versus the injection? Why not always use the injection method in states that you can?
Great question. It is very site specific. So sometimes we walk on a site and, for example, there will be a row of 20 to 30 foot tall beech trees all in a row. Trying to inject each of those, even if they're each, maybe 10-inch diameter and pruned rather short, will be very time consuming. Whereas a skilled ground applicator can knock out that treatment on all of those trees in a pretty short period of time. So, there are pros and cons to the time and expense. There are also pros and cons to how close it is to water. There is a different fungicide in the broad form product that is not so good for aquatic organisms at all. And so that's a fungicide that we don't need, but unfortunately it's in that product. And that's one of the reasons, the main reason why we don't use broad form if there's a risk of it being, drifting into waterways. So some of it is from an ecological responsibility perspective as well.
Thanks. Another question from Paulo. Could you speculate how much time and research will be needed for a large forest scale treatment, if any, at this point?
I've been very glad to see several research groups, including us, setting up these long-term forest scale treatment plots, because anything in tree research is long-term, right? But then anything in forestry level research is even longer term. So this silviculture-based study that we are actively setting up this spring, we intend to monitor for at least 5 years to get a snapshot of how the trees change in these forest blocks during that time. I believe Cameron McIntyre with the Forest Service up north is doing a similar time scale. He's looking at thinning and also treatments using the potassium phosphate products in the woods. I think Davey and some folks in Ohio are also continuing to look at the potassium phosphate products and other possible treatments at a forest stand level. So this is a long-term goal for sure. But what we've learned from these individual tree treatments often has direct translations to tools that are later used for forest patch situations. It's very similar to the development of treatments for hemlock woolly adelgid, where we started off figuring out how to protect individual trees and then carried some of that information and research over to help manage hemlock woolly adelgid in forested areas.
Thanks. If there's any other question, oh, here's one from Nick. Do you think that Illinois, Indiana, Missouri, et cetera, should be looking to treat their key beaches now?
Not to treat, but to scout, it certainly wouldn't hurt. There have been numerous cases where beech leaf disease seemingly jumped surprisingly long distances, and whether that was carried by, a storm or birds is unknown. But it's very easy to scout for this disease. Those banding symptoms are very easy to see. And it does not take too much time to go out and look at your beech trees immediately after leaf out in the late spring and look up into the canopy on a nice sunny day and see those very obvious banding symptoms. There are some lookalike issues to be aware of, and if you're interested, feel free to reach out. We can send pictures or you look it up online, but some of the aphid damage on American beech also causes a type of banding that can look similar, and there's an area 5 mite that causes some velvet-like growth called erinium that can look similar. So there have been cases where lookalikes were misidentified as BLD, but we always encourage monitoring and scouting your trees, regardless of the local risk. It's always a good idea.
I think I might have a question building off this. Since it's not something we're dealing with in Iowa, I hope I don't sound ignorant on my question. And Paula, I'll ask yours here in a second. I'm thinking about our members, people on this call, people who are members of the UCFS, and they're the forester for a city or a community, and they're dealing with lots of different perspectives in their community. Maybe they have urban woodlands, they've got homeowners who have beech on their property, they've got trees that they're dealing with in their communities. And this might be too broad, maybe it's something that the whole group needs to talk about. Is there a way that they should be messaging? Have you seen anything come through for this in particular, lessons we've learned from other diseases of how you message this to community members, to elected officials that you want to have take this seriously, start prepping them as we're still in research on some of these treatment options? Is that too broad? Yes. Do you feel like you can answer that, or is that something we need to take to the group?
I can answer it at least a couple of things I've observed. So it's very difficult to find a balance between communicating urgency versus communicating that knee-jerk reactions should also be avoided, because often they go hand in hand. We speak urgency, 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 and the result is a knee-jerk reaction. So for example, we want to spread the word about BLD and how severe it is, but we do not want people to be going out there and telling someone who has a beech tree with a little bit of banding from BLD that they have to go out and chop down this tree right away. And that drives me crazy. So there are cases where that knee-jerk reaction can be more destructive than the disease itself. So I think communicating urgency, that it is something to monitor for and to start collecting data on which beech trees are important, whether they're very healthy, they have good reproduction potential, they have historical value, and then taking care of them ahead of BLD getting there is a big one, because as a progressive disease, there's pretty clear evidence that, if we have a healthy tree to begin with, then it will take much, much longer for, in most cases, a disease like this to kill the tree. So having a tree that's healthy to start with will give us more time to figure out good management strategies in the long term. And that's not always the case. Like I've seen trees severely affected in coastal New England where it's just sweeping through. But in most cases, we have a little bit of time to think about the correct next step and not sweep in and start chopping down the tree right away.
Yeah. Thanks. Appreciate that. Yeah, that ongoing information, always something that urban foresters are having to do about issues in the urban forest, but keeping up on that information early on sounds really important. Let's see, let me go back up. We've got 5 more minutes here. Paulo asked, on all of these trials, do you have indication of any resistance shown by American or European beech cultivars?
Yes, this is a big topic of discussion. We don't have very many cultivars of American beech in the trade, but of course there will be some genetic diversity of American beech in the forests. And as BLD moves through different sections of the country, we anticipate and hope that some American beech may show some natural resistance or a hypersensitive response, which would be a good thing. We have not observed that yet on our sites. We have observed what others have seen from some of the European beech cultivars, and I know Rich Culls is delving into this, where some of the European beech cultivars, like Rosia marginata, are just not affected in the same way. And we really struggle to detect the nematode in Rosia marginata, which is interesting. We have our theories of why that might be. It could very well be something physical, like that particular cultivar has very, very, very fuzzy twigs and buds. So maybe that physical barrier there is inhibiting some of the nematode's movement, just a theory. But we do intend to look at this, and arboreta play a big role in this. The Holden Arboretum, they have a good diversity of beech. The Arboretum that Harvard has a lot of beech. Dawes Arboretum in Ohio is right on the border of BLD. They have an enormous beech collection. So as BLD starts to hit these valuable collections of beech genetic diversity in one spot, it will be really interesting to see what we can learn from all of those curated collections and how BLD affects the cultivars differently. So if you're curious about that, it's certainly worth looking out for. Often good research projects are derived from ideas that came from an anecdotal finding. So it's worth looking for.
Mm-hmm. Yeah. In the chat, Carla has dropped the CEU link. You'll click on that and add your ISA information. And again, we will submit those on your behalf. As we come up to the top of the hour, there's one more question here. Cody asks, scouting was mentioned. Is there a connected network for reporting so that there is interstate awareness?
Yes, there are a lot of networks that look for invasive pests and diseases, including BLD. In our world, all of the samples that we get from the field, and those are our arborists, plant healthcare specialists, they come to our diagnostics lab, and all of those records are submitted to the National Plant Diagnostic Network. The Forestry Service also collects a lot of information and produces those excellent maps. So in most cases, your state and extension officials will be connected with one of those networks that reports where the problem is. Not always necessarily going to the same database, but it usually is being captured somewhere. So it depends who you're working with and which state you are, but try to contact your local pathologist that handles tree problems and or forestry problems. Make sure that they're aware of it if it's in a new area. Most states still have a good diagnostics laboratory where if you send it to them for confirmation, they will put that data point in the same data repository that we do. So yes, it is good to capture this information. That's how we learn about diseases and where they're moving to, and often is also the basis of getting support to study them further for a lot of state folks. So it is very important. Please report.
Yeah, thanks, Dr. Borden. Great advice. Well, we are up at the top of the hour, and actually what's on the screen right now are the next 3 learning series events that we'll be holding with Bartlett in June, RFP in contract writing, in September, species diversity, and December, tree ordinances. So we'll get those posted very soon. The CEU link is in the chat. Thank you, Bartlett, for your support of the learning series. Thank you, Dr. Borden, for all this excellent information on BLD, and we will look to see you guys next time. Thanks, everybody. Bye.